So the agenda for today's session is broken down into 4 sections. We'll start off with Joe just giving a high-level introduction on what Morgan Foods is all about. I'll talk to you about what Interlock's all about. And then we're going to turn the stage over to Joe to talk about the Morgan Foods business journey. And then after that, I'll talk to you about the Morgan Foods Maz journey, where we'll talk about what we've done with Maz, monitor, health, and predict, and also do a little bit of a demo and show you some of the data that we're pulling into Maz Monitor.
How many of you have ever heard of Morgan Foods before? Anybody? Well, a few of y'all, good deal. How many of you have ever had any great value beans or soups or broths or anything like that? Probably a lot more of you, right? So we do produce a lot of products for Walmart under the Great Value brand. Morgan Foods is, we're celebrating our 125th anniversary this year. We're on our 4th generation of Morgan. It started out with J.S. Morgan back in 1899. He had a grocery store and wanted a way to preserve the food that all the farmers in the southern Indiana area were producing. So he started a cannery. His son succeeded him, I.C. Morgan, and he really saw the benefit of national production, mass production, turned a very small cannery into a very large cannery, and at that point we even had the largest fleet of privately owned trucks in the country, so pretty big operation. IC was succeeded by his son, Jack Morgan. Jack Morgan was kind of a visionary, and I think it's worthy to point out. He really saw the advantage of preventive maintenance, so way before his time really. And he also always looked at continuous improvement, wanting to better efficiencies and decrease costs. So he was ahead of everybody probably in the 50s and 60s on that. We're on our 4th generation of Morgan now. Mr. John Morgan still in charge. And John really hired a bunch of people in the canning industry, in engineering and maintenance to kind of bring the company to the 21st century. So that's kind of where we are right now. We do have 2 facilities. Our facility in Austin, Indiana, which is about 30 miles north of Louisville, Kentucky. During our busy season, which is soup season, as you can imagine, between September and December, we employ about 800 people there. We also have a septic packaging facility in Saline, Michigan. And so in Austin, we produce canned beans, soups, ready-to-serve soups, broths. Saline, Michigan is a septic processing plant. And if you're familiar with the box broths, where there's beef or vegetable or whatever, they produce that up there. So, next slide, please.
All right. So as Joe alluded here, the Morgan Foods is a very successful company, and there's part of the reason for their success is what they do for maintenance practices. And it's an honor to work with a company like Morgan Foods who takes their maintenance practices seriously and is always on the cutting edge with wanting to do more with their software systems. So what is Interlock all about? Interlock is a platinum IBM business partner. We have been doing 100% Maximo for over 19 years, and we are truly a one-stop Maximo shop. So whatever your Maximo need is, we can fulfill that need for you. We have some incentives, promotional offers around Maz upgrades and our Interlock cloud offering. So if you are looking to migrate to a cloud solution, come see us. We are very proud of a lot of the awards that we've won, previous MaximoWorlds. We have our Mobile Informer solution that won mobility awards. And at this MaximoWorld last year, we won the Maximo Data Governance Program and also the Best Maximo Implementation. So if you are also looking to upgrade your Maz on-prem, we also offer assistance in that area. If you're a little nervous about how you're going to maintain that with the new skills of Red Hat OpenShift, we can offer those IMS services in infrastructure managed services and also offer AMS for the application managed services. So come see us whether or not you're looking to upgrade, whether it's a hosting solution or on-prem.
A little bit about our journey. I've been with the company for 6 years, and as I was getting through the company, we were implementing Maximo 7.6 1.2. The operation of the facility, we were largely run to failure, very reactive. Maintenance downtime was in the mid 25% range. So my charge when I first got there was, hey, let's stop the bleeding. So we were able to do that by developing a PM program. We got that implemented, carried on and did SAP integrations to bring our MRO inventory, and Maximo together. And of course, for about 3 years, we got our maintenance downtime down to about 9.5%. And we've kind of plateaued at that point. So we started looking for other solutions, and Interlock's been a real good partner with us. So we looked at them and implemented MAS 8.0. So that's kind of our vision, and that's where we're going right now. I know this is a eye chart, I'm sorry about that, but we approach our PM program in a PDCA format, so plan, do, check, and act. The cool thing about Maximo and Maximo Informer and the fact that it's web-based is anyone can enter a work request. So whether it's my maintenance technicians, maintenance supervision, operational supervision, they all can enter a work request. One of our very good partners is our Safe Quality Food Department. So we're under USDA and FDA. So what they do is they do an SQF audit, which is one of our big audits that we go through annually. And they do that monthly. And they enter work requests based on what they see from the facility, maybe equipment problems and all that. So they're a big partner for us with that. The plan portion of it, our maintenance planner gets work orders, a work request, and approves them or disapproves them. If it's disapproved, usually it's because of a duplicate entry. But once approved, it becomes a work order, and we start planning resources against that. So, MRO parts, exterior contractors, our technicians, whatever we need. And then we do it. So our scheduler gets with the production scheduler. They look at the calendars, see when the best opportunity is to do that work, and we go ahead and execute it. The technicians execute that with supervision, looking and making sure they're doing the PMs correctly. And from that point, we go to kind of the check portion where our maintenance managers do audits of those PMs to make sure they're adequate. And then the final thing is act. I believe that a PM program is never completely finished, right? Because you're always going to have breakdowns that you didn't expect that a PM didn't address. You're going to have new equipment coming into the house, that kind of thing. So we're always constantly looking to upgrade our PMs in our PM process. So as we were going down this journey, some of the obstacles both with the first Maximo 7.6 and MAS 8.0 is we are a 125-year-old company, and we have a lot of tenured people. Now, and it's family-owned. Now, being a family-owned and a smaller company, that has its good and bad points. The good point is that we're very agile. So if we see something that has a good return on investment for us, it's easier for us to execute that. Some of the bad parts of that is you have those people that have been in place for a long period of time with the kind of mentality that we've always done it this way. They're very resistant to change. We also are unionized, a very strong Teamsters union. And anytime we do anything different, we have to make sure that we vet that through the union, make sure they understand why we're doing what we're doing, because they get kind of testy with that kind of stuff. We also, a lot of times, and I've heard this in one of the presentations this morning, we've become somewhat stovepiped at times. So my maintenance group may be doing one initiative, but it might impact procurement, for example. And a lot of times we don't do that crosstalk until a problem arises, but we're getting better at that. So the final thing is, I don't know if anybody's with the food industry here or not, but our sanitation processes. So if you look at a canning line system, you have the raw products, which goes to the cook deck. You have the packaging goods, which is empty can. That comes to the filling area. The can's filled, it's seamed, and it goes to be cooked. That middle part, filling and seaming, gets a pretty robust sanitation. So is very, very damaging to motors and things like that. So we really have to constantly educate those folks. It's a lot of turnover because of the junior people. So it's just a matter of educating, training. It seems like we have to repeat that cycle. It never ends. So when we're looking at MAS 8.0, what predictive tools do we already have out there? So we have hundreds of field devices that's already out there that provide data to us, whether it's photo eyes, amp draws on the motors, speeds, temperatures. We have a lot of that data already in place out there. So there's a lot of companies out there that will put vibration devices on a motor, and they can import that from MAS, or they'll monitor it for you. What that becomes in my processing area is a target with the sanitation folks. They'll blast it off with water and things like that. So we have to make sure we get that kind of stuff out of the sanitation area. But another thing that we use is we have a seamer operator, and that person is responsible for putting lids on the seamer, which is kind of like the heartbeat of the whole line, and capturing the downtime. But really, depending on their experience level, all they really know is, hey, I'm not getting any cans from a depalletizer, my seamer's jammed up, my filler's jammed up, and the empty can line's not running. So 4 buckets, very general buckets. So I pretty well know what my downtime amount is. It's just getting that granularity on it. It's very difficult using that. Much the same thing is true with our maintenance technicians. On their PMs and corrective maintenance work orders, some of the technicians are absolutely fantastic, and they will put time down to the second, exactly what was completed, where it was completed, be very accurate. But then on the other side of the spectrum, you get some very, very broad data. So that's just one of those things too. We have to constantly train. We also looked at the use of thermal imaging and ultrasonic technologies. We do thermal imaging now just twice a year at all the major electrical switches and things like that. We do vibration analysis now. We have an outside company that comes in. They do approximately 60 critical assets that we have in the facility, and they make a recommendation, a predictive recommendation as to if we need to address that piece of equipment or not. And it's only done quarterly though, so we wanted to do something that would give us more of a real-time feel for what we needed. So the method that we chose, we did a proof of principle, and we just completed that successfully. So our line 54 is the most technologically advanced line that we have in the facility. We have 9 processing lines, 4 of which are very technologically advanced. 3 of them are our high-speed lines. 54 is one of our high-speed bean lines. It can run cans at 1,100 cans a minute. If you've never seen that, it's something to see. So some of the beverage industries can run up to 1,500, 1,600 cans per minute, but it's an aluminum can. We have a steel can. It's a big difference. So we decided to look at 6 critical assets, all motors, and to choose a particular piece of data that we already knew that we were capturing. And what happens is we have all of our field devices out there. We use Rockwell platforms, so that data is imported to our Rockwell platform. Our HMI uses a system called Proxy Pro to visually display everything. And if there's any kind of fault on the line anywhere, that the Proxy Pro will report that data, that error, whatever it is. So I'm thinking instead of buying all these devices, let's just use what we already have out there. And so it made a lot of sense to us to do that. But these 6 motors that we're looking at, they're all critical assets. They're all single points of failure. And so we decided to use those. 2 of them are if they're down, we're done. It'll be a lot of downtime associated with it. Not necessarily because we don't have the part. It's just just to access them is very, very time consuming. And then we have 4 that were just bad actors that had very short mean time between failures. And so our data of choice was amp draw. So we can see that on ProxyPro. It's a pretty good indicator if one of your power transmission devices, whether it be a gearbox or a bearing, is going bad, your amp draw is going to be high. If your motor's going bad, your amp draw is going to be high. So we're able to set some parameters. So if we see that going outside the parameters, then it's an indication we need to do something.
That's fine.
So this is just kind of a visual way ProxyPro looks. I know it looks like a bunch of gobbledygook up there, but if you see up in the upper left-hand corner, you have the decal there. That's the empty cans coming in. You have a filler which deposits the beans into the can, and then a seamer that puts the seam on the can. And so we already have all these assets, labeled a specific way. They're categorized in a hierarchy. And so if you see the assets over there, everybody was familiar with those. We knew that we could pull that data, and we just had to figure out a good way to get it from field device, ProxyPro, and then ProxyPro to Massa 8.0. So just a little bit of recap of our journey. So in 2018, we went live with Maximo 7.6.1.2. And we use SAP as our ERP of choice. So in terms of our MRO inventory and the whole financial situation behind that, we had to integrate Maximo and SAP, which has gone pretty well. Interlock assisted us with the mobile informer, which is absolutely fantastic with our technicians, because before the little CMS system we were using, it was all print pieces of paper and hand them out. They signed off when they did it. This allows the guys to access the PMs, corrective maintenance work orders. We've put pictures into a lot of the areas and things like that, where they have a real good feel for what they're looking at, what they need to do, and that. So as I said before, we kind of got a little bit stagnant there. I'm not satisfied with 9.5% maintenance downtime. It's still quite a lot. So in July 2023, we went live with MAS 8.0. And again, we had to go through the integration process with SAP and update their informer and that kind of thing. So Interlock's been like a fantastic partner for us, helped us out every step of the way. And we look forward to going from MAS manage to predict, health, and monitor.
All right. So as Joe mentioned here, they are on MAS Manage, which is probably one of the most critical pieces to developing a roadmap to implement all the other MAS applications. So getting yourself to MAS Manage essentially is just bringing the 7613 upgraded version. And once you're stabilized on MAS Manage, you can start to plan out how you're going to leverage the additional pieces of MAS, such as monitor, health, and predict. So shortly after Morgan Foods went live with Manage, we started planning out on how we can do the monitor, health, and predict proof of concept. And just shortly before this MaximoWorld event, we completed that proof of concept. So as Joe mentioned, we picked 6 critical assets on their state-of-the-art line 54. From that, we picked a sensor reading that they were already collecting and just rerouting that into MAS monitor. The sensor reading there was the current and amp pull. From there, with their sensor readings coming in, we created various alerts, various anomalies to assess the operational performance of that asset, and using those readings to make a determination whether or not to create a service request or work order within Manage. And then, of course, we did a health configuration, doing their health criticality and risk scores, and then also made use of a proof of concept for MAS Predict and enabling some predict models such as predicted failure date. So I'll go over how that looks. But now that this proof of concept is done, we can successfully plan the next phase of this journey. And that's really to start assessing which other critical assets you want to pull into this process, the additional sensor readings you want to pull in. Joe mentioned vibration analysis. For this PLC, we just did current. And then we also want to ensure that from a scaling perspective that we scale the solution appropriately so that we can have an abundant sources of devices and also metrics. And then of course, enhanced reporting and full implementation of MAS Monitor and Predict. Okay, so Maximo Application Suite. It's essentially a new operating model, okay? Everybody on the left here knows and loves Maximo 7613. Upgraded version of that is MAS Manage. And this is the traditional work order management, asset management that we all know and love. This is where your asset repository exists, where your PMs, job plans exist, and where you start to do your work order and failure reporting. So moving on into Monitor, you now have a different dimension where you can examine operational status of your asset. So this is where you can implement an IoT gateway and with the stream of data coming in, create anomaly detections for that stream of data or alerts if there's any thresholds that are breached. And then if certain conditions are met, you can form another way to alert that an asset needs to be looked at. Moving on to health, this is where we assess health, criticality, and risk scores. Once it's configured, you can look at assets with low health, high criticality, high risk, and just as another dimension to be able to raise an alert as to why you want that asset looked after. And then last but not least, up here in the top right corner is Predict, where the AI and machine learning algorithms are put in place. So this is where you have the predictive maintenance functionality and where there are 4 available Predict models that could be employed. There are custom models that could be employed that are a little bit more involved, but for the sake of this proof of concept, we use 3 of those models. So what did we do for MAS Manage? Okay, they've been using MAS Manage for all these years. And one of the things that we did is we assessed their asset repository. With our asset repository, there were key pieces of data that were required to optimally use the other MAS applications. We ensured that installation dates were accurate. We ensured that expected life was accurate. We created a new lead time value, which was a measure that outlined how long it would take for an asset to come in if the current asset failed. And I'll talk a little bit more about that. And then, of course, we have meters. So we actually imported the monitor readings for current into Manage to be able to use the functionality within Manage. We created condition monitoring configurations and then also just showed the meters within Manage. We continued to use the pre-PM schedules, the next PM next due date. And then we also had to rework a little bit of their work orders. You need to ensure that with your work orders, you have a very succinct way of identifying which work orders are resulting in asset failures. And an example of that is to use failure class with a specific problem code. Okay, so this is where the fun starts. The shiny new application with MAS, MAS Monitor. We created what we call a privileged IoT gateway. And what that gateway enables you to do is to continuously send a stream of data. And if by chance you had a new device that you wanted to enable, you can send that data and Monitor will automatically create that device and link it to the asset. So it's a very efficient way of introducing new devices. With the Monitor, we configured the device and device types. And this is where we developed and configured the metrics, which in this case was the current and AMP draw. We created dimensions, and then we also created aggregates and transformations. We created alerts and anomalies and configured that to be visually shown on a dashboard. And you could see here that with Monitor, there are a number of anomaly detection methods. For this proof of concept, we use the generalized anomaly score. But there are other anomaly scores, such as Fourier transformation, saliency-based anomaly scores. So each of these different scores has a specific use case. And then on the right there, you can see that we have that manage layer always seamlessly integrating into monitor. So this here is the high-level integration architecture. Morgan Foods was already working with a company called Matrix Technologies. They were managing their Rockwell equipment. One of our partners there, John Lee, who is the Senior Manager of Manufacturing Intelligence, and his team, we worked very closely together to create that integration. They used the Factory Talk Gateway, and we used the MQTT protocol to send the streams of data into manage. Okay. So let's have a little bit of fun here and show you what that looks like. This here is the Suite Navigator. Has anybody are there any MAS users here? Can we just have a show of hands? Okay. Most of you are not MAS users. So when you log into the MAS, you land into this Suite Navigator page. And based on what you have installed, you see the tiles for the applications that you're installed. And for whatever application you want to launch, you simply click the launch button, or the launch link here, or you use the app switcher to launch your application of choice. So I'm just going to click here, the monitor, and I'm going to show you what we configured for Morgan Foods here. Okay, so this is the landing page of Monitor, okay? I'm going to quickly show you here what we set up for this proof of concept. I'm going to go to the device setup here, click on the Monitor device type, just show you the configuration. So here is where we set up the metric. You hear me talk a lot about metric, but what this really translates into is the sensor reading. And in this case, it's current with a unit of amps. Okay, looking into data here, we created a series of batch data metrics, and this is where you configure your alerts and your anomaly detections. Here is an example of an alert for high current. So if we had a motor that was showing high current, we would raise an alert. We have here an anomaly score to detect any anomalies. We created various aggregations where, since we were getting such verbose data every second or every minute, we wanted to consolidate that for one reading per hour. And this was the max amp reading per hour, just so that we can show more data on a graph. We also created a transformation for max amp. So for every motor, we wanted to be able to display the maximum amp pull. And then, of course, we configured dashboards. So once your dashboards are configured and pinned, you can go to the dashboard application and view the dashboards as managed here. You can see here that we have all of our different motors. We have a dashboard for each of the motors, and then also a dashboard for the entire device type. Okay. Another way to see the dashboard is to go to the monitor application here. I know I'm going pretty fast, guys, but I want to be able to show you everything here. So pick up the device here. I'm just going to pull this and pull up this dashboard. And then you can see some of the loading here. And I'll show you what that looks like. Okay. So one of the things here that I just wanted to show here is you can set up a filter. I'm just going to do a custom range. And what I'm going to do here is to show you what data look like. Some data here, 9 o'clock a.m. to 9:30 a.m. Let's say yesterday. I'm just going to hit apply. And then what you can see is that each of these different tiles here will adjust to that time frame. And I'll just describe to you how intuitive some of these graphs will look. Okay, so I wanted to highlight here this transfer pump, M7040. You can see here that the maximum amps are a value of 10, and then you could see here a cyclical process where the amp is going up, then down, up, then down. Here's another example of a brine pump where you have your maximum amp reading, and you have a number of points that are exceeding that maximum threshold. Okay? So with the anomaly detection, you could see here that motor 7040 is showing a flat line at 0. So it actually recognized that this was a normal pattern going up and down and didn't detect any anomalies in this time period. Here is an example here where we reached some values that exceeded the threshold. So when you look at line 6020 brine pump, you could see here that we have high anomaly alerts. So based on this, you can make an informed decision to trigger a service request or a work order into Manage for someone to have a look at. And along that is a dashboard where you can have all of your alerts. So this is an example. We talked about the brine pump here. You could see here that an alert was raised, and you can walk through each of these different alerts, go ahead and change statuses, assign them to a different owner, but ultimately, from this screen, you can go ahead and create a service request for someone to take a look at that asset. This form here is populated with default information, and then what you could see here is a link to the dashboard so that from Manage, if you wanted to look at the dashboard, you can go ahead and click that. I'm just going to hit cancel here, but really this is a demonstration of another form or another way that you can bring awareness to an asset based on the operational status of your asset through the sensor readings. Okay. All right. From current slide. Okay, so I took you through a walkthrough of MAS Monitor. Now I'd like to talk to you about MAS Health. Okay, so this is the application that allows you to configure health, criticality, and risk scores. Okay, with Morgan Foods, when you look at the health reading, this is really a measure of how your asset is performing, the condition of your asset. So what we did is we used a contributor of that meter reading as a form of a way to determine health. Mean time between failures, so if that value was low, you would know that there was frequent asset failures. Or asset age. It's commonly known that as your asset ages, that the condition of the health of that asset may degrade. So we use those three contributors. For criticality, we used asset priority. So this is the important and how essential this asset is to your organization. We also use lead time. So this was the configured field that we added, which was a measure of how long it would take that asset to be brought into the organization if the current asset failed. So if that number were great and your asset was down, that could lead to financial losses within your organization. So you want to make sure that if your asset is very critical, that you maintain scores there so that you can action appropriately. Risk. So this is the likelihood of potential impact. We use remaining useful life, mean time between failure, and lead time. Okay, so what does the standard workflow look like in Maximo Health? There is a concept, which I will show you, called word queues, where you can go in and based on health readings, health scores, you can make informed decisions as another avenue to be able to create service requests and work orders. And then again, on the far right there, you have that seamless integration of manage and monitor. So let's take a dive into MAS to show you how that health is configured. Okay, so here is the app switcher. I'm just going to go ahead and switch that app and take you to the health application. Noticing that this internet connection is a little slow. Okay, so this is the landing page of health. Okay, it's a tabular view. We've set up a filter to pull up all the line 54 assets. You can easily sort each of these by clicking the top of the column. And if you wanted to adjust the column displays, you can easily do so by clicking the Manage Columns features and simply just check or uncheck fields that you want. And then boom, your view will have all those column updates. So what I'm going to do here is I'm going to pull up an asset here that is showing low health. I'll pull this up here. And then right away you can kind of see a story. You can see here that health is poor. You could see here that it's a highly critical asset. And you could see here that there is a high risk here. And if you wanted some more details as to the health score, you can see here that the health is composed of a contributor of meter value, mean time between failure, and age, and then the weighted percentages for each of those values. You could see here that there's a score of 0 for this health. And if you drill down into that, you could see that it's the current meter value, and it's displaying a value of 9, and which is exceeding the maximum amp pull. Okay, so that's just to be able to pull the details. You can do the same thing with criticality here, with priority. You can see here that risk has a different set of contributors. I do want to emphasize that each of these contributors can be configured based on, a specific asset type, and also based on your business needs. Okay, just going into each of these additional tiles, you can kind of see a little bit more of the picture. You can see here that the asset is 2.2 years old. This is an asset with an expected life of 3 years. So you could see that there's 27.8% remaining useful life. Again, you could use that to make an informed decision as to whether you want somebody to look at that asset. Here is the lead time here. So this is really just a demonstration that we configured a new field against the asset, and within health, we were able to display that data through a configuration in health. And then here is the next PM date, which is being pulled directly from the PM application. You got a question here?
Yeah, first one. So for the house score formulas, did you use a lot of the out-of-box
Oh,
options?
one moment, please. Let me go ahead and get a microphone on you, please. Who was that?
So for the house score formulas, did you use a lot of the out-of-box options, or were there's like a lot of, I guess, self-development for those formulas?
Yes. Short answer is we created some of our own contributors and also created some out of the box. You could see that the ones that start with FAC here are out of the box contributors. And this is a meter value that we configured. So it's a way where you can identify that you want to look up a meter reading and then identify which meter you want to pull from. So it's a mixture of both. Yeah. All right, so what does the workflow look like in, how would a user use this application? So going into asset, you're pulled up with this tabular view, but there is also another matrix view. And if you pull up here the view related to criticality and health, you can see a story here. You could see here that there's one asset with a high need for action. You could see that there are 5 with a medium need. So in looking at this one, you could see that this asset is in poor condition and high criticality. Pull this up. Your list of assets would come up here, and I would pick this asset. This is the same asset that we're looking at. And if you decided that you needed somebody to look at this asset, you would just simply do the action, create service request, and create work order. So this is really demonstrating another way of being able to create awareness for this asset for someone to look into. All right, so that is health. Okay. Okay, Predict. So Predict is the other shiny and new tool within the MAS application suite. It uses artificial intelligence, machine learning algorithms to perform predictive maintenance. So there are 4 out-of-the-box models that could be deployed. One is the predicted failure date, which gives estimated time for failure for your asset. There's the probability of failure, so failure probability within a time window. And then there's also an anomaly detection. So the difference between this anomaly detection and the monitor anomaly detection is that in addition to showing just the anomaly with sensor readings in general, it'll also compare the readings for when there is an asset failure. Okay? There's also an end-of-life model that could be employed, but for Morgan Foods, we did not employ that. This model does require that you have minimum of 10 assets with 2 of them in decommission status. Okay? And then on the right there, again, my consistent message of manage and monitor seamlessly integrating to predict. All right. So let's go ahead and show you predict. So again, we have the app switcher here. I am going to go to predict and then show you here that we'll pull up the asset. And one of the new things that you'll notice here is the predictions window. So there's a lot of work that comes into configuring predict. But when you look into predict, you see some very quick insights and values where you can make an informed decision as to whether or not you want to have someone look at that asset. Estimated time of failure, 995 days. So as you get more historical data into the system with your meter readings, you can get more accurate measure. There's also failure probability. So within a 3-day window, there's about a 13% failure of probability. And then you can see here that the last anomaly detected was August the 2nd. Our threshold was 1.05, and it was a 1.81 reading. Here is a history over time. You can see here the threshold of 1.05 and all the different anomalies that were detected.
I'm sorry, we are at time. Can we do a quick wrap-up?
Yes. I'm sorry? Yeah.
We are at time. Can we just do a quick wrap-up?
Wrap up? Okay.
Yeah.
Yes. So that is tradition. And what I'll do is I'll just show this last slide here. Okay. So this slide actually had some animation, which is not working. So what I'll do is I'll just display this. So with the whole Maximo Application Suite, it's a closed-loop process with continuous automation. Here you have your MAS core, which manages your user licensing and authorization, which manages access to manage, monitor, predict, and help. Manages the heart of the overall solution where the data is being consumed by monitor, consumed by predict, and consumed by health. Monitor is also critical where data is consumed by health and predict. The entire loop is closed when you start creating work orders from predict, monitor, and health. Once all those work orders are back to manage and your work orders are worked upon, the entire cycle repeats. So as you have more iterations, you will have continuous optimization.
Thank you
folks,
very
thank you.
much.
Yeah.